What are the charge carrier transport principles? In this video, the two transport mechanisms will be discussed: diffusion and drift. We will discuss that for net movement of charge carriers, either a concentration gradient is required or an electric field is required. Let's consider a free gas of particles at a temperature larger than the absolute zero. In case of a free electron gas, these particles are electrons. The particles have kinetic energy and can move freely around. All particles move around in a so-called random walk. They move in random directions until collide with another particle. After the collisions, both particles will move in a different direction and its velocity of the particle is changed. In a free electron gas, the interaction of the particles is ruled by the Coulomb-Coulomb interactions. The particles not really collide into each other, but they bend each other's trajectories. Let's consider the situation that the density of the particles is uniformly distributed, so no density gradient exists. On average, the particle with a random walk will have no net movement. Just as many particles will move to the right as will move to the left. Just as many particles will move to up as will move down. Now we consider a non-uniform particle distribution. At the right you see that the particle density is higher than at the left. In other words, a density gradient is present going from the right to the left. If these particles all move randomly around, the flux of particles to the volume with lower density on the left will be higher than the flux of the particles to the volume with a higher density on the right. There will be a net movement of particles until the density is uniformly distributed. In the current situation, the density is uniform, no gradient exists, so there is no net movement of particles due to diffusion. The net movement of particles induced by density gradient is called diffusion. It can be described by Fick's law of diffusion. Je, in this case, the electron current density, Q is the elementary charge, D is the diffusion coefficient of the electron, and dN dx represents the density gradient in direction x. The same equation is valid for holes. The fusion of electrons results in a net movement of electrons to the location with lower electron densities. The fusion of holes results in a net movement of holes to the location with lower hole densities. There is no net diffusion if no density gradient exists. Now we move to the second transport mechanism, drift. Charged particles like electrons and holes can also be moved under the influence of an electric field. If a positively charged hole is positioned in an electric field, it will experience an electric force in the direction of the electric field. Consequently, it will start moving in that direction. A negatively charged electron will experience a force in the opposite direction of the electric field. The electron will start moving in a direction opposite to the electric field. The current density, so charge per second per area, induced by an electric field is given by the product of the density of the electrons, the electron charge Q, the mobility constant mu, and the electric field E. Similar, the whole current density, charge per second per area, induced by an electric field is given by the product of the density of the holes and the electron charge Q, the mobility mu, and the electric field E. The presence of an electric field can also be represented in an electronic band diagram. In the figure you can see a conduction and valence band. In this figure, an electric field is pointing to the left and induces a slope over the valence and conduction band. The slope of the electronic band is positive in the direction of the electric field. It is important to remember that the excited electrons in the conduction band will on average always move down the slope of the conduction band when present, whereas the holes will on average always move up the slope of the valence band when present. In summary, diffusion and drift are the two mechanisms which are responsible for charge transport in solar cells. Holes and electrons have net movements due to either a density gradient of an electric field. How far free charge carriers can travel depend on the lifetime of their mobile states, or in other words, the loss mechanisms. So far, we have discussed the generation and transport of charge carriers. In the next video, we will discuss some loss mechanisms of charge carriers and how that might impact its transport. So, see you in the next video lecture.